Hello and welcome to Astronomy Daily. I'm Anna.
And I'm Avery. It is Wednesday, April 8th, 2026. And what a week it has been.
We are deep into what might be the most extraordinary few days in human spaceflight since 1972. Artemis 2 is heading home, and we are going to walk you through exactly where the crew is right now, what happened on flight day 7, and what to expect as they come screaming back through the atmosphere on Friday.
Screaming is right. We are talking 25,000 miles per hour, the fastest crewed re-entry in history. But more on that in a moment.
We have also got a cargo launch delay that has created one of the most beautifully poetic scheduling coincidences we have ever seen in spaceflight. Some planet-shaking new science about how Earth actually formed, fresh data from an alien comet courtesy of a spacecraft designed for Jupiter's moons,
A new comet for skywatchers to get excited about after last week's spectacular disappointment.
and then to close the show today, something a little different, a mystery, a space mystery that is 30 years old and has never been solved.
I have been looking forward to this one all day, I won't lie.
So have I. Let's get into it. This is Astronomy Daily, Season 5, Episode 84.
Right, so let's set the scene. Artemis 2 launched on April 1st. Yes, April Fool's Day, and no, it was not a joke. And the crew of 4 have already done the most extraordinary thing. On Monday, flight day 6, they flew around the far side of the moon. They set a new record for the furthest humans have ever been, 252,756 miles. Nobody in human history has ever been that far.
And flight day 7, which was yesterday, Tuesday, was the day after all that drama, the science debrief day.
The come down day.
Well, sort of. They woke up to Tokyo Drifting by Glass Animals and Denzel Curry, and I genuinely love whoever selects these wake-up songs is having an absolute blast.
The playlist creation on Artemis 2 has been exceptional. Somebody at NASA is doing their best work.
They woke up 36,000 miles from the moon, 236,000 miles from Earth. And the big item on the agenda was a 15-minute audio call, ship to ship, with the crew aboard the International Space Station.
So you have 4 astronauts who have just been further from Earth than any human in over 50 years calling up the International Space Station, which from where Orion was sitting must have felt practically next door.
Right, relatively speaking. They spoke with NASA astronauts Jessica Meir, Jack Hathaway, Chris Williams, and ESA's Sophie Adenaught. Just imagine that conversation. So how was the moon? Well, bit far.
And after that, the science debrief. The Artemis 2 lunar science team had a full debrief session with the crew to capture everything they observed during the flyby, while the memories were still sharp.
Which makes complete sense, right? These 4 people have just seen parts of the moon no human eye has ever seen directly, the far side. Craters like Vavilov and the Oriental Basin, an ancient lava field on the border of the moon's near and far side that's almost impossible to see from Earth. You want those impressions captured immediately.
And then, in the evening, at about 9 p.m. Eastern, Orion fired the first of 3 trajectory correction burns to begin fine-tuning the return path to Earth.
So we are officially in the home stretch, and flight day 8, which is today, the crew has 2 key tasks. First, a radiation shelter construction demonstration.
Which sounds alarming, but is actually a planned drill. They practice assembling a makeshift radiation shelter inside Orion, using available materials, in case of a solar event during a deep space mission. Exactly the kind of emergency preparedness you need locked in before Artemis 3 heads to the lunar surface.
And second, manual piloting tests. The crew gets to hand fly Orion directly, which, given that computers handle basically everything on this mission, must feel a bit like being handed the wheel.
And then Friday, April 10th, splashdown.
Flight day 10. Orion re-enters the atmosphere at 25,000 miles per hour. That is the fastest crewed re-entry ever attempted. The heat shield, which caused so much concern and engineering work before this mission, will be put to its ultimate test.
And collecting data from that re-entry is actually one of the core mission objectives. So NASA will be watching those heat shield readings very closely.
Splashdown is scheduled for about 8 p.m. Eastern off the coast of San Diego. The USS John P. Murtha, a Navy amphibious transport dock ship, will be waiting. The crew will be recovered by helicopter, taken aboard for medical evaluation, then flown back to Houston.
And that will be it. The first time humans have returned from beyond Earth orbit since Apollo 17 in 1972. Mission complete.
But right now, Reed Wiseman, Victor Glover, Christina Koch, and Jeremy Hansen are heading home, and we could not be more excited for them.
All right, from the crew heading back to Earth to a cargo ship heading up to the space station, with a slight detour through the weather forecast.
Yes, so as we reported yesterday, Northrop Grumman's Cygnus CRS-24 mission was supposed to launch today, Wednesday morning, from Cape Canaveral on SpaceX Falcon 9, carrying about 11,000 pounds of cargo to the International Space Station.
But the weather at Space Launch Complex 40 had other ideas, and teams have pushed the launch to Friday, April 10th, targeting 8:03 in the morning Eastern. Backup opportunity on Saturday, the 11th, if needed.
Now, here's why this matters beyond just a weather delay. Friday, April 10th is also the day Artemis 2 splashdowns.
So on the same day, 4 astronauts return from the moon, the furthest humans have been from Earth in over 50 years. A fresh cargo ship launches towards the space station simultaneously.
Cape Canaveral is going to be having quite a Friday.
The spacecraft itself is the Cygnus XL, the larger configuration, carrying about 11,000 pounds of pressurized cargo. Northrop Grumman has named this one the SS Stephen R. Nagel, in honor of the NASA astronaut who flew 4 shuttle missions and logged over 720 hours in space.
Beautiful tradition naming these cargo ships. And the science aboard CRS-24 is genuinely interesting. There's a new module for the Cold Atom Lab on the station, NASA's quantum science facility, to help investigate dark matter and potentially improve computing technology.
There's also hardware to produce greater numbers of therapeutic stem cells for blood diseases and cancer, model organisms for a gut microbiome study, and a receiver to improve space weather models that protect GPS and radar infrastructure.
So it's not just food and equipment. This is a proper science delivery.
Once it arrives, Cygnus doesn't dock automatically the way Dragon does. Astronauts Chris Williams and Jack Hathaway will use the Canadarm2 robotic arm to grab it and bring it in. They've been practicing. There was a report last week of them running simulations together in the cupola.
And Cygnus is scheduled to stay at the station until October, before undocking with several thousand pounds of trash and burning up on re-entry. A rather unglamorous end, but a useful one.
Weather permitting, Friday should be quite the day.
Okay, story 3. And this one is a genuine rewrite of something we thought we understood.
Where did Earth come from? We know the broad answer. 4.5 billion years ago, a cloud of gas and dust collapsed, the sun formed, and the leftover material clumped into planets. But where exactly did the specific material that became Earth come from?
For decades, the accepted model was that Earth got a significant chunk of its building material from the outer solar system, from beyond Jupiter. Estimates ranged from 6% to as much as 40% of Earth's mass. And the reason this mattered is water. Scientists needed that outer solar system contribution to explain where Earth's oceans came from, because the inner solar system was thought to be too dry.
But a new study from ETH Zurich, published in the journal Nature Astronomy, has just turned that on its head. Planetary scientists Paolo Sosi and Dan Bauer analyze isotopic ratios of meteorites from across the solar system and compare them to Earth's composition. Their conclusion? Earth formed almost entirely from inner solar system material. The outer solar system contribution, less than 2%, and possibly nothing at all.
Now, isotopes are essentially atomic fingerprints. Different regions of the solar system produce slightly different ratios of the same elements, and you can use those signatures to trace where material originated. Previous studies mostly looked at 1 or 2 isotopic systems. Saucy and Bauer looked at 10.
10 different isotopic systems analyzed with statistical methods rarely used in geochemistry. And when you look at all 10 together, the picture is unambiguous. Earth is built of non-carbonaceous material. inner solar system stuff through and through.
Which immediately raises an enormous question. If Earth didn't get its water from the outer solar system, from comets and water-rich asteroids drifting inward, where did the water come from?
And the answer, according to this study, is it was already here. Water and volatile elements must have been present in the inner solar system from the very beginning. We just didn't realize it.
And why was so little outer solar system material reaching Earth in the first place? Jupiter. Jupiter formed extremely quickly and grew enormous, and its gravity carved a gap in the young protoplanetary disk, essentially a barrier between the inner and outer solar system. This study suggests that barrier was almost completely impermeable. Almost nothing got through.
Jupiter, the bouncer of the solar system. Sorry, outer solar system material, not tonight.
One of the researchers, Dan Bauer, said, "We were truly astonished to find that Earth is composed entirely from inner solar system material, distinct from any combination of existing meteorites. Even they didn't expect this result."
The implications are genuinely big. If water was already present in the inner solar system, that changes how we think about the conditions that made life possible here. And it has implications for other planetary systems. Rocky planets around sun-like stars might be wetter than we assumed.
It's the kind of result that makes you look at the ground beneath your feet differently. This material formed locally, billions of years ago, without much help from the wider solar system. Jupiter kept the neighborhood tidy.
And Earth's water was here from the start, which is kind of beautiful, actually.
Digging with space science, and this one involves an alien comet, a spacecraft on its way to Jupiter's moons, and an instrument that was never designed to do what it ended up doing.
We have followed 3I ATLS closely on this show. Quick catch-up. 3I ATLS is an interstellar comet, only the third object ever confirmed to have entered our solar system from interstellar space. Discovered in July 2025, reached its closest approach to the Sun on October 29th. And when I say it was moving fast, 250,000 kilometers per hour. Nothing that formed in our solar system moves like that.
It is genuinely a visitor from another star system. We have no idea which one.
In November 2025, ESA's JUICE spacecraft, the Jupiter Icy Moons Explorer, currently en route to Jupiter, was in a fortunate position to observe 3I ATLS from deep space, just 4 days after perihelion. The observations were difficult. It took until February 2026 for the data to reach Earth.
And ESA has now published the findings, and the headline number is extraordinary. JUICE's MAGIS spectrometer detected 2,000 kilograms of water vapor being expelled by 3I ATLS every single second.
2,000 kilograms per second.
To give you a sense of scale, that is the equivalent of approximately 70 Olympic swimming pools of water every single day, just evaporating off the surface of this comet into space.
Which tells you this is a very active comet, water-rich at least on the surface. Though there's an interesting wrinkle. Its carbon dioxide to water ratio is higher than you'd typically expect from a solar system comet, which either means the nucleus is genuinely CO2 rich, or there's a thick insulating crust hiding ice underneath.
Neither of which we can determine from here. 3I ATLS has now passed Jupiter and is heading out of the solar system. It will never return.
And here's the part I find most extraordinary. ESA's navigation camera, designed for navigating near Jupiter's moons, looking at surfaces a few hundred kilometers below, also contributed to the science. It provided a unique vantage point from deep space that helped ESA's planetary defense team refine the comet's orbital path to 10 times better accuracy than Earth-based observations alone could achieve.
An instrument designed for one job, unexpectedly doing something completely different and doing it brilliantly. That is science at its best.
What I keep coming back to is the age of 3I ATLS. Based on its trajectory, this comet may be billions of years older than the solar system itself. It's not just from another star, it may be older than our sun. It has been traveling through interstellar space for longer than Earth has existed.
And it spent about a year passing through our backyard, and we watched it as carefully as we could, and now it's gone. Everything we will ever know about 3I ATLS, we know already.
Everything we will ever know. I love that and find it completely haunting in equal measure. Right. After last week's heartbreak with Comet MAPS, the sun grazer that did not survive its close pass with the sun, which we covered in yesterday's episode, the good news is that April is not done with comets.
Not even close. Comet C 2025 R3, discovered by the Pan-STARRS survey, is now the prime target for April skywatching, and it's looking genuinely promising.
Where MAPS was unpredictable and dramatic, a Kretz sun grazer diving to within 100,000 miles of the sun's surface, Pan-STARRS is a more conventional comet. Predictable orbit, manageable approach, the reliable act that shows up when the headliner cancels.
And its timing is good. Perihelion, closest approach to the sun, is around April 20th. Closest approach to Earth is April 27th, when it comes within about 44 million miles of us. At peak brightness, it's expected to reach approximately magnitude 8.
Now, magnitude 8 means you will not see it with the naked eye under normal skies, but binoculars will absolutely do the job. Any small telescope will give you a lovely view. You're looking for a fuzzy smudge, possibly with a faint tail extending away from the sun.
For Northern Hemisphere listeners, look east in the pre-dawn sky from mid-April through the end of the month. It will be in the constellations Pegasus and Pisces. A good star app, Stellarium, Sky Safari, Star Walk 2, will give you exact positioning.
And for our listeners in Australia and New Zealand, your window is actually in early May in the evening sky. Look west after sunset. Dark skies will significantly help. Get away from city lights if you can.
Comet brightness predictions can shift. They famously don't always behave, so keep checking Sky and Telescope or Universe Today as we get closer to perihelion. But right now, the forecast looks encouraging.
Think of it as the universe offering a consolation prize after MAPS. It's a perfectly lovely comet and it deserves our attention.
One comet destroyed, one comet incoming. April is very on brand for the solar system. All right, story 6. And today we're doing something a little different to close the show.
We are going back, 30 years back, to one of the strangest and most overlooked stories in the history of space exploration. A mission that was built with extraordinary ambition, launched into tragedy, and then vanished. And nobody has ever found it.
This is the story of Mars 96.
Let's set the scene. It's 1996. The Cold War has been over for 5 years. Russia and the United States are, for the first time in decades, not rivals in space, they're partners. Shuttle Mir is underway. The International Space Station is being designed. There is genuine optimism about what a post-Cold War space age could look like.
And in that spirit of optimism, an extraordinary mission is being assembled. Russia is leading it, but it is genuinely multinational. Science payloads from Germany, France, Italy, Poland, Spain, Belgium, Finland, Austria, and the United States. NASA's Jet Propulsion Lab contributing 2 instruments. This is what cooperation looks like when people choose it.
The spacecraft itself is remarkable. At over 6,500 kilograms, it is the largest interplanetary spacecraft humans had ever launched. More than 40 science instruments aboard. And its ambition is staggering. It would study Mars simultaneously from orbit, from the surface, and from below it.
From below it?
From below it. Mars 96 was carrying 2 surface penetrators, hardened cylindrical probes specifically engineered to strike the Martian ground at 70 to 80 meters per second and bury themselves several meters underground, where they would measure seismic activity and heat flow for up to a year.
That is actually extraordinary. A networked subsurface Mars science station in 1996?
It was also carrying 2 surface landers, small autonomous stations that would descend using an airbag system to cushion their landing. An airbag landing concept that NASA's Mars Pathfinder would use to enormous public acclaim just months later.
So the technology was there, the ambition was there, the international partnership was there. And on the night of November 16, 1996, the Proton K rocket lifted off from Baikonur Cosmodrome.
And then, almost immediately, something went catastrophically wrong.
The spacecraft entered its parking orbit successfully. The upper stage was supposed to fire and push Mars 96 toward interplanetary velocity. It didn't. It either failed to ignite properly or shut down almost immediately.
And here's a detail that stays with me. The onboard autopilot kept executing its programmed sequence. It had no way of knowing the mission had already failed. So it separated from the upper stage. It fired its own engine. It unfolded its solar panels. It began transmitting telemetry.
For a brief moment, controllers in Crimea thought it had worked. The signals were there. The spacecraft was doing everything it was supposed to.
Until the orbital data arrived and the realization set in. Mars 96 had never left Earth orbit. It was trapped. And it was about to come back down.
Very rapidly.
Early assessments suggested the debris might land over Australia, which prompted President Clinton to call Prime Minister John Howard directly to offer support for any recovery operation. As tracking data was refined, the projected impact zone shifted, eventually settling on a corridor across the eastern Pacific and into northern Chile and Bolivia.
And in the Andes, that same night, witnesses reported something unusual. A brilliant object moving slowly across the sky. Not the sudden flash of a meteor. Something that lasted nearly a minute, jetting glowing fragments that briefly lit the thin mountain air before fading.
One of those witnesses was an electronics specialist at the European Southern Observatory, who later said he had no illusions that it was anything other than a piece of space debris.
U.S. Space Command later acknowledged, in writing, "We believe it is reasonable that the impact was in fact on land."
And then, nothing. A search was never performed. Nobody went looking. 30 years later, the final resting place of Mars 96 is completely unknown.
And here is where it gets genuinely strange. Those surface penetrators, built to survive striking Mars at 70 to 80 meters per second, had thick, compact casings, engineered for violent impact. It is entirely possible that one or both of them survived re-entry and are sitting in the Andes right now, largely intact.
Hardware built for Mars in a Chilean valley that nobody has ever looked for.
The spacecraft was also carrying 18 radioisotope heater units, small plutonium-powered heaters specifically engineered to survive catastrophic events, including atmospheric re-entry. Similar units survived the uncontrolled crash of a Soviet satellite over northern Canada in 1978. So these two could still be out there.
The Space Review published a beautiful retrospective on this story just this week, and they put it perfectly. A spacecraft engineered to be tracked from hundreds of millions of kilometers away may instead have vanished somewhere on Earth, a world mapped in exquisite detail by satellites, aircraft, and ordinary people carrying cameras in their pockets. Somewhere in a dry valley across the windswept Altiplano, or among the salt flats and volcanic slopes of the high Andes, hardware built for another planet may still be lying quietly under open sky.
Could we find it today? With modern satellite imagery, drone surveys, AI pattern recognition, why has nobody gone looking in 30 years?
That is a question I genuinely don't have an answer to.
There is a coda to this story that I think deserves to be said. Many of Mars 96's science teams didn't give up. They went on to contribute to ESA's Mars Express mission, launched in 2003, which is still operating today.
And one instrument, the Alpha Proton X-ray Spectrometer, developed by the University of Chicago for Mars 96, actually reached Mars. A closely related version of it flew aboard NASA's Mars Pathfinder, launched just months after the crash. It landed on Mars in 1997 and began returning chemical readings from the surface.
One instrument made it, carrying forward the work of the mission that never got there.
Somewhere in the Andes, hardware built for another planet sits silent and unfound. And somewhere on Mars, a cousin of that same hardware did exactly what it was built to do. The mission failed. The science, in part, survived.
Russia has never successfully sent an independent Mars mission since Mars 96. Worth sitting with, especially this week as we watch Artemis 2 completing one of the most successful crewed missions in decades.
Space is hard. Every mission we celebrate, every safe return, every trajectory burn that fires on time is built on decades of missions that didn't make it. Mars 96 is one of them.
And if you're ever in the Andes, keep your eyes open.
And that is Astronomy Daily for Wednesday, April the 8th, 2026. What a lineup today.
We had Artemis 2 heading home, a cargo ship delayed into a spectacular Friday, the origin story of the ground beneath your feet rewritten, an alien comet saying its final farewell, a new comet arriving just in time, and a 30-year-old mystery that nobody has solved.
If you enjoyed today's episode, please subscribe wherever you get your podcasts. It genuinely makes a difference in helping us reach more space enthusiasts around the world.
Leave us a review if you have a moment. Tell a friend. Find us on social media. We are at Astro Daily Pod on Twitter and X, Instagram, TikTok, and YouTube. Links and full show notes at astronomydaily.io.
We will be back tomorrow with the latest from space.
Until then, for Avery, I'm Anna.
And for Anna, I'm Avery. Keep looking up. We'll see you tomorrow.
Astronomy Daily.